Okay, good morning. Hi, how are you? So welcome to The Physical World Meets the Web. My name is Maximiliano, right? It's a long name. You can call me Max, that's fine. And in these 50 minutes, we're going to talk about the web and how the web is getting into the physical world, right, from different angles. First, really quickly, I'm from Argentina, right? I'm a mobile web developer. I have been doing web development since 1995, so that's a long time ago. And I have also doing a lot of mobile apps, native apps and mobile web apps. I'm a trainer, so I'm usually doing trainings in companies on mobile apps, web apps, and also web performance. And I have written some books, right, with a lot of translations. And the latest one, High Performance Mobile Web and Programming the Mobile Web, both from O'Reilly Media. And I have also some video trainings on different topics, usually around the web. So all the slides, links, and tests that we're going to see during this talk will be available on that link. So I will tweet that link later also. Even if you have Android or iOS, you can get that link directly through the physical web. And that's something that we're going to talk in a minute. So questions, yes, please. We'll have some minutes at the end. Okay, I have some microphones there. So also I will be here like 3 days. So let's start. So the whole idea, we're going to cover 5 topics here. So we're going to start talking about the mobile space today, IoT, and the physical world. Then we're going to get into a spec, something really real that is known as the physical web. Then we will cover briefly progressive web apps. Then how we're going to connect to the physical web through different web APIs. And finally, this is kind of a surprise. It wasn't there in the outline. We're going to talk about also how to mix the web with some of these new words, right? Probably you know about VR, right? Virtual reality. But I'm not sure if you know what MR is, right? So but we will talk about that later. So about mobile and IoT. So I'm traveling a lot. So in the last 6 to 7 years, I've been in 50 different countries. 50, not 15, right? 50. So that means around 120 different airports. Okay? So I was last year at Finland, at the Helsinki airport, and I have seen that particular sign. So it says the airport in your pocket, right? And it's asking me to download the official app. And if you think about that, yeah, it's cool because I can get information about my flight, right? Delays, maybe if I have a gate change. But the problem is I don't want to download probably 120 apps, 1 app per airport. So it doesn't make too much sense. Another thing is that we have now the Internet of Things. Now, everything has Bluetooth or Wi-Fi. Everything can be managed by a mobile app or mobile device, or even a desktop. So everything is connected to the web. And that means that you also need to install several apps. So I'm not sure about you, but I'm a gadget guy. Fortunately for me, I work on this field, so it's a nice excuse to buy a lot of gadgets. So just to give you an example, right? These are these just a couple of apps that I have right now in my phone, just to, for example, connect to my home. So I have an alarm. I have a Harmony device, so that's basically I can use my TV. Also, I can turn on my PlayStation from there, right? I can connect all my devices to that Harmony device. I have another app for a camera, security camera. So that's my wife, by the way. I have another app to manage my lights. Okay, so different native apps. Also, I have another app for taking a temperature, right, for a gadget that will let you do that. And even I have an app for the conference. So, and if you are conference people, right, probably you go yearly to different conferences, and you need to install every conference app. So here we have a problem, right? So we don't want to spam our home screen with thousands of apps just to connect to one physical thing, because the conference is also a physical thing. We are here, right? So you need an app so you can get the agenda, or you can, I don't know, submit information to the conference. So that's usually a problem that we have, okay? So we have too many devices, too many things that relies on the web and on apps, and we don't want to spam our home screen. Also, there is another specific situation. So let's say you go to your friend's house, and your friend has a gadget. For example, it can be a smart headphone. It can be a smart TV. And your friend wants to share something on your TV, your smart TV. Right now, your friend needs to download probably 100 megabytes for that app before sharing something on your TV. And that happens with every gadget that we have right now. We need to go and download an app. And here, when the web comes to save us, right? The web has now new standards, new specs that will let you work with this. So let's say that right now, it's kind of experimental, to be honest, but it's probably happening during the next year. So probably the next year will be the best year for the web coming into the physical space. So every gadget, every sensor, every device that you have at home, in your car, your bike, so everything will have mobile support. But we don't want to install apps for each of those gadgets. And probably we don't want everything to be public. So probably I don't want my smart TV app to be in the store. It's something from my house, because we're going to create our own gadgets, probably. So that's why right now we have a problem, and now let's see how to solve it with the web. And the first thing we're going to see is something called the physical web. So the physical web, it's an open approach, and the whole idea here is to enable interactions with physical objects and locations. An object can be, for example, the smart TV. It can be to manage my remote control, or it can be a location, for example, the conference venue. Okay, so that's the whole idea. It's an open spec. It comes from Google, but it's open, so basically everyone can implement it. So far, let's say that only Google is using it. It's based on beacons that are BLA, that's Bluetooth Low Energy. So here I have one. So a beacon looks like this. In fact, it's this big because it has 2 AA batteries there. But if not, it will be probably smaller. So that's a Bluetooth beacon. So it's basically something that is streaming, it's broadcasting, in this case, a standard packet that has a URL inside. That's the whole idea. And because it can be small, it can be attached to any device. And it will become cheaper and cheaper with time. So basically, everything in this room can have a Bluetooth Low Energy beacon streaming a physical web URL. Also, there is the spec supports MDNS over Wi-Fi. So that's probably better for private networks. So if I'm in your Wi-Fi network, then I can get that URL, but nobody else. For example, your neighbors that lives in another floor, right? That because of Bluetooth, they might get that URL too. And the whole goal here is just to broadcast URLs. And if you're working with the web, you probably know the advantages of URLs. They can identify one specific part of a website or an app or a web app. And also, they can be used as a way to open native apps. So today, iOS, Android, Windows Phone, every OS supports the ability to open a native app from a URL and deep linking inside that native app to one specific part of the app. So the physical web spec is not just for the browser. It can also be used by native apps. But here we are going to focus on the web. So the whole idea comes with something called the Eddystone protocol, okay, that was promoted by Google. It's an open spec. And basically, every device, every small device, can broadcast URLs to you right now. In fact, right now, we have a URL being broadcasted from here. Probably you're thinking, hey, this is like the Bluetooth era, like 12 years ago, probably, where when you get into a shopping mall, you were getting a spam from every shop sending you Bluetooth messages or something like that. That's not the way how it works. So in this case, this little device is not really watching you. It's not really seeing your devices. It's the other way around. So when you open your phone and you have a physical web-compatible browser, then that browser will let you see the URLs around you, but those beacons are not really seeing you. So they cannot spam you. So if you want to start with this, you can buy one of these beacons. Right now, it can be around 15 euros. You can also try and test this directly on your Android phone. For example, there is a free app on the Android and the Google Play Store called Beacon Toy, where you can basically stream the URL using the Eddystone protocol from an Android phone or a tablet. It can also, you have also options over Wi-Fi and also for computers. So there are a lot of Node.js scripts that you can download and run on Windows, Linux, or Mac, and then stream URL from your computer. For example, every speaker here can stream a URL for, can be a survey, can be URLs right from the computer directly without any Bluetooth gadget. So you can just stream the URL. So you can now start broadcasting URLs. Fortunately for us, we have support today for this. So, but before that, let me show you some videos here. I don't need the audio for this part. So, for example, this is the lost dog video. So we can attach a small beacon to our dog. So basically, when it gets lost, we can go to a website and say, hey, now it's lost, and now everyone that that found the dog will get the URL saying, hey, call us or something like that because that dog is lost, right? And probably you say, hey, that's too expensive. Well, probably in a year, that will cost €1, right? The whole beacon. And it has a battery. Probably the battery is more expensive than the beacon itself. Other example that is probably more interesting for you is, for example, a parking meter. So right now, if you want to pay a parking slot with your phone, you need to download an app, right? And probably you don't have your app for every city in the world. So now you can go with your phone, right, be near that parking meter and get the URL so you can pay. So that's the whole idea. So everything can have a physical web URL. Everything, right? Even it can be here the registration. So the whole registration process can be just a URL that is being streamed from the main entrance. When you get there, you check in directly without installing any app. So the current support is Chrome on Android. So if you have Chrome on Android, right, you can try it. You need to enable Bluetooth on your phone. And if you have Android 6, you need to go and enable that directly in the Chrome settings. I will show you how to do that in a minute. Also, if you have iOS, but on iOS, you must use Chrome on iOS. So you need to have Chrome on iOS installed, and then add Chrome on iOS to your today's screen, to the widget, and you will get the URL from there. So this is how it looks like from an Android point of view. When you are near URLs, you will get that notification saying the physical web page is nearby. And for getting that, you need to go to settings and enable that. So let me show you a quick live demo. Again, I'm streaming this URL, so you can try yourself. But anyway, I have here my phone. Let's try to stream my OK, and now, of course, it's not working. An error occurred. So let me get out the USB and try again. It was working before, of course. OK. Yeah, I accept. Yeah, there we are. Or probably not. Yeah. It's coming. Yeah, there we are. So here I'm here in Android, right? That's my Android phone. You're seeing my Android phone. Because I have a physical web around me, you can see that physical web page is nearby notification, right? That's the one. Physical web page is nearby notification. And if I click there, if I tap there with my phone, right, I will get that URL. And of course, if I click there, I will go to the browser. So that URL is the one where you're going to get all the links and all the samples that we're going to see during the talk. So, and if you have iOS, it's also pretty similar. So, and to enable that, you just need to Chrome. You need to go to Chrome, settings, and I think it was in advanced. You need to go and find the right one. Go back. So this is how it works. So you can install if you want. some clients on your desktop. So I have one, so it's a physical web scan. That's for the Mac, but they're also for Windows. So it's scanning for physical web beacons here from my desktop also. So it can work also on desktop. Of course, there is no browser today supporting this from scratch. So there we have that URL, right, coming from this beacon. So that's the whole idea of the physical web, to stream URLs, to broadcast URLs in physical places. It can be physical devices. It can be a Coke machine. Right? It can be the dog. It can be a bus stop, right? Anything. It can be a conference. It's an open standard, and anything can broadcast a URL. So now let's talk about something called progressive web apps really quickly, because, yeah, you can say, OK, that's cool, but we are still talking about the website, right? So what happens if the connection is not working so well? And what happens, for example, if you want to send notifications in the case of the airport? So the great feature of the airport application, the native application, is that I can get notifications even if I'm not using the app. If, for example, my gate has changed. Well, progressive web apps, it's something that will help us in the web space to do that. So it's an open definition. It was embraced by Google. It was originated by Google. In fact, yesterday, there was an event in Amsterdam called the Progressive Web App Summit. But now it's also followed by Firefox, Opera, Samsung, and Microsoft. So they will have support just in a few months. So the Progressive Web App, right, it's a way to create an app-like experience using latest web technologies in a progressive way. So features are instant loading. So it will load instantly as a native app. We can discover that you are from Google or from a physical web. It's network independent. Of course, we will need to get that app at least once. But when we have that app installed, or web app installed, then it works anyway if there is connection or if there is no connection. It's responsive, so it will adapt the layout to different screen sizes. We can install it. We can have an icon on the home screen, and in a few months, we will have an icon in the application launcher menu on Android. It's secure. It goes over HTTPS, mandatory. We can link, so it's linkable, so meaning that we can deep linking inside one particular part of that app. It's re-engageable, so we can send push notifications to that user after the user has left our web app. And that's one of the key parts of a progressive web app. It works everywhere, even on non-compatible browser, and it's fast. It has a fast UI, an app-like experience. So I don't have this webby-like experience that if I touch on a link, it has like a 500 milliseconds delay or something like that. So the whole idea, the whole big pattern here is called progressive enhancement. And the whole idea is to add different layers like an onion based on current compatibility. So it will start as a website that will work everywhere, on iPhone, on Android, on all devices. And if the browser is compatible with new specs and new technologies, then we are going to use them to enhance the experience. That's the whole idea of progressive enhancement. And so it's a website. So it starts as a normal website, but it will add native installation through a new API. I will mention the API in a minute. It will also add web push notifications and also hardware and platform access. We're going to talk about that in just 5 minutes. So we have APIs now, so we can also take advantage of the hardware, the sensors of the device, and also the communication to other devices nearby. In terms of compatibility, this is right now the current compatibility of progressive web apps. So they are working today in Chrome. That's, for example, Chrome on Android. On Firefox, it has partial support. Opera is also supporting progressive web apps. Edge has announced 2 days ago that it will have support for progressive web apps in the next version. So it's also available right now in the beta version. And I'm not sure if you know the last icon there. That's the Samsung Internet Browser. So if you have a Galaxy device, you probably know that icon is the the browser that has the name Internet. Okay, so it's a Chromium-based browser from Samsung, and you can have progressive web apps there. And it's not on iOS, right? So iOS is not supporting the latest features for a progressive web app. But anyway, it will work on iOS because it will start just as a website. Of course, it won't have all the nice features like push notification messages, but it will work, okay? So let me show you now a quick live demo of progressive web apps. You can try this directly on your phone. So on the links from this talk, you have a progressive web app gallery link that is pwa.rocks. There you will be able to find a lot of progressive web apps that you can try directly on your phone. Let's go back here. So I have already some progressive web apps here. So this is Flipkart. It's an Indian e-commerce website. It's pretty nice how it works, right? It's really smooth. So you can see it's a website. So I'm inside the browser. If I'm getting into this particular website more than one in a week or something like that, I will see a banner asking the user, hey, do you want to install this to your home screen? That will probably change in the near future with better versions. But here I can also use add to home screen. But remember, the user will get a notification anyway to install the website. So I can add this to the home screen. Now Flickr was added to my home screen. And if I go there, I already have it anyway. It's that one, Flipkart Lite. That one. So if I open that, now you can see I will see exactly the same experience, but now it's in full screen mode. So it's an app now from a user's point of view. It works offline. So if I don't have connection, it will work anyway. Of course, probably I will not be able to make the final purchase, but I will try the app. It has a very nice UI, and it can have push notification messages, right? Let me show you another one really quickly. Go back to Chrome. That's not Chrome. Chrome. And here I have Washington Post. So the Washington Post has also a progressive web app right now. So you can see it's a website. It works pretty well. I'm still inside the browser, but I can install this in the home screen, and I think I already have it somewhere. That one, Washington Post. So now I'm in full screen. So it's an app, right? But it's just HTML. Also, I can go offline, so I can turn on airplane mode. So now I'm offline. And now you can see that I can still work with the app, at least some of the sections that has content, for example, opinion. Opinion has content, but not politics because I'm offline. Okay, so I don't have all the sections there. But the app is still working, right, because it's a progressive web app. So that's the whole idea. Let's go back to the presentation. That's the whole idea of a progressive web app. In terms of specs, we're using HTML5, so HTML, CSS, JavaScript, all the standard languages that you know. But we're also using service workers. So that's the technology that will let you work offline, for example. The web app manifest is a spec from the W3C that will let you install the app. We have an icon on the home screen. Okay, so that's the one that adds that progressive feature of adding and installing the app into the home screen. And also, we have web push, the web push API that will let us send notifications to the user after the user has closed the browser. Okay, we can still send notifications to the user. And optionally, we can use any of the hardware APIs that we will see in a minute. So progressive web app will get the best of native and the web world. We can serve app-like experiences. The user can use it from the browser just as a website, or it can install it, and we can send push messages. So for example, if I go to the airport, right, I will get through the physical web a URL to the progressive web app. So I will get the app from the airport, and I decide if I want to install it or not. Right? If not, I will use it from the browser. And even if I use it from the browser, I can get push messages. It's like a temporary app. It will be there until I get my flight. Probably I will not get into the Helsinki airport for a year, so I don't want the app in my home screen all the time. But if you live in Helsinki, probably you want the app. So it's user's choice, not developer's choice, to have that icon on the home screen. So now let's talk about web APIs. So we are going to talk about device sensors that we have right now on the web that we can use. Then we're going to mention web audio and web Bluetooth. First, about device sensors. Mostly useful on mobile devices. So some of these APIs are available on desktop, but they are more useful on mobile devices, on mobile browsers. They will use the sensors and the hardware that we already have in these smartphones. And we have different levels. We have some mature APIs, meaning that we can use it right now on all the browsers. We have some experimental APIs. So these APIs might change in the future, and probably they're working just on 1 or 2 different platforms. And finally, we have APIs that are not really here right now. So we have the spec, and they will come in the following month, but we don't have any support. Or it's really, really experimental, meaning that probably you need to download a different compilation of that browser to try it. So in terms of the mature APIs, we have the geolocation, the access to accelerometer and magnetometer, right? The compass, that's a magnetometer. The gyroscope also. The camera to take a picture, like a still picture. And if you want to know more about these APIs, I will have another talk this Thursday, right? Breaking the limits of the web, that we're going to see some of these mature APIs that we have available right now. But here in this talk, I will probably talk more about the other APIs, the more experimental ones, that will get us abilities into the physical space. And these experimental APIs, for example, are get user media, ambient light, speech recognition and synthesis, web MIDI. And let's try to see some examples of these APIs before getting into web audio and web Bluetooth. So get user media, probably you know this API, it's not so new really. It allows us to get the stream video from the camera. We can use it to recognize objects, faces, QR codes. There are already right now a lot of open source frameworks out there to do this, so you don't need to do all the math yourselves. So I can like look at you and see your face, and I can like recognize if you're smiling or not. For example, from JavaScript, from a mobile device, inside the website or a progressive web app. And it can be used for augmented reality. So that's pretty cool, from a website. So the code is pretty simple usually. You have the get user media function, where you say, hey, I want video. You can also say optionally if you want audio or not. Not every browser supports the ability to disable the audio, for example. When you say that, basically you will get a callback with the stream. And you can use the stream directly on JavaScript. You can manipulate that stream on a canvas. That's an API in HTML5 where you can draw on the screen, for example. And you can get basically the bitmap of each frame. So you can do whatever you want there. Right now, compatibility is pretty good, not on iOS yet. It's not coming on iOS 10, but Apple is working on a version, so it will probably come on 10.1 or something like that. But it's on all other browsers today. So you can get the raw information from the camera on a website. So the demo is pretty simple. Probably you know that. So I think we can try from here, get your user media API demo. So now you see me there. So just that, right? Let me turn off. But basically, so I'm in infinite loop right there, right? So it's just that, right? You get the raw information, and it's up to you when I want to do this. You have also other links there that you can test later for QR code reading, for face recognition. So you can do pretty cool stuff there. So not a very interesting demo, because I have more interesting demos. Then web MIDI. It will let you connect to music devices. Okay? So keyboards, guitars, drum machines, lighting systems. So basically, I can manage that particular device that we have there that is managing the audio here. And I can do it from the web, from JavaScript. So because that device probably supports MIDI, it's a very old standard in the music industry, in the audio industry. We can send and receive MIDI messages Okay, that it's not just information about the audio or notes. It can also be, for example, signals like turn on that light, turn off that light, that sort of things. So in terms of the API, you just request media access. Then you will have a callback. When it's OK, you will get like the media interface, and you will get all the inputs from there. You will like scroll all the inputs, and you will listen for messages. So that's all. So the device will send messages, and you can send messages to the device. The device can be connected through any interface. It can be USB. It can be wireless. Usually it's USB right now. But it's up to the OS at that point, not up to the browser. Okay, how the user is connecting that device to your browser. So the current support is just Chrome and Opera today. Okay, so that's why it's experimental. Then we have Ambient light that it will let us get current information about light conditions. So it's being measured in luxes. I don't know if you know about that. But it's pretty simple, right? It's just an event that we have on the window. It's device light, and that's all. So let me show you that in action. So I can use the phone, but let's use the desktop here. So that's the light level right now. It's 10, right? So I have the sensors here in my Mac, so I can even use my finger to change it. But if I turn on my flashlight, right, you can see I'm sending more light to the sensor. Okay, so it's working also on mobile. So you can, for example, know if the user is in a dark room or not. Or you can have a game saying, hey, turn off the light, turn on the light. So turn on the light to access the next level, wherever, right? You can do that, right, on the web, on a website or on a progressive web app. The API is pretty simple to use. And right now it's working on Firefox. It will work on Edge in the near future. And today it's working on Chrome if you enable a flag. Mental web features. So it will become available probably in a few months to every Chrome. Okay, so it's today experimental, but it will work anyway. But if you have the latest version of Firefox, it works there without any flag. You need to have support for that hardware feature. So for example, if you're on a typical desktop computer, you don't have a light sensor there. Okay, so it's not going to work because you don't have the sensor. If you have a laptop or a mobile phone or a tablet, probably you have the sensor because it's the one that is adjusting the brightness of the screen. Then, this is pretty cool. It's a speech synthesis and recognition. It lets us interact with the user with the voice. So we can let the web speak, and we can let the web listen to us. Okay? So this is, for example, how you make the web to speak. You create a new speech synthesis object. You set a couple of things there, and then you say, speak. That's all. And if you want to get your voice, you create a new speak recognition. You set a couple of arguments there, and then you listen for the result. And the result will come with a confidence. So I think it's the user has just said this. So it can be 100%, or it can be 20%, and then the text. It's more interesting to see this in action. So I think I have it here. So this is a synthesis. So I can, like, hello, Krakow. And let's turn on. Well, you're not listening because it's going there. Because I'm using HDMI, so the audio is going through HDMI. So it's getting there. But it's working. I can try it on my phone. You can try it directly there. So it's talking. And the other one is you can try it on your phone, remember. It's the recognition API. So I can say, I want to start in English. Hello, Krakow. It's working, right? So it's pretty simple. You need to wait, because you can see it's changing while I'm speaking. So it's waiting for me, and sometimes it will change the previous recognition until it's getting the final one. And this is working in Chrome, as you can see, so you can use it right now. And it's working on your mobile phone, too. In terms of compatibility, the synthesis, so to speak, is working even on iOS, so you can try it on your iPhone. So Chrome, Safari, Opera, and in the future, Edge. And on Firefox, you need to enable the flag. And the recognition part, it's Chrome and Opera only today. In terms of future APIs that will come, we have geofencing. That's the ability to know when the user gets in and out of some geo area. Web USB and Web NFC. So I already mentioned this, but geofencing will activate the website or the Progressive website, the Progressive web app, when the user enters or leaves a geographical area. So I can know when the user gets out of the building or in the building. Web USB, it lets us connect to any USB hardware that we connect to the device. And Web NFC for near-field communication. So tap to play, tap to share, so I can tap this to my wherever device I have and get information from there. Okay, so these are future APIs. They are not there yet. And then we have web audio. So you can say, hey, what's the relationship between web audio and hardware? Well, we can generate dynamic audio with this API so that will listen to low-level audio information. And we can use this for ultrasound communication with devices. This is pretty cool. So this is how it looks like from a code point of view. It's using a library, SonicNet. So you just create a socket. You send some message, right? And to receive that message, you create a server and receive that message. So it's pretty simple. I have a video for this. So in this video, it's turning off the Wi-Fi, so it's not using any other communication. And you can see from Chrome, it's sending messages from Chrome on the phone. It's sending messages to Chrome on the computer, just using audio. And it can be ultrasound, so you're not going to hear anything, unless you're a dog, probably. But it works at distance, right? It's using audio, right, to communicate from and to devices using just USB. So, for example, there are some devices such as Chromecast that are using this technique right now. So you're not going to hear anything, but sound is going from one point to the other one. So that's pretty cool. In terms of compatibility, it's everywhere. So web audio is everywhere today. And then we have web Bluetooth that it's pretty cool. It's brand new. The spec is not even finished today. But we can scan Bluetooth devices. We can scan the services that we have available. And we can connect to those services. Send and receive data using any Bluetooth protocol. So this is huge for Access IoT, because every IoT device is usually Bluetooth. And we can mix this with the physical web. So for example, I can get the URL for a Progressive web app from the Coke machine, and then I can use the web Bluetooth API to request a Coke, right, without going to the cloud to do that. We can just send the message directly using Bluetooth. It will be better with the next version of Bluetooth because it will have like broader reach. So in terms of the code, it looks like too much code because we need to request the device. Then we connect to the device, then we get the primary service, then the characteristic, and then we start a notification. So, ooh. But this code is usually better if you see it from a new point of view, from the new ECMAScript syntax that's using arrow functions. So it's much easier to read those arrow functions instead of using callbacks. So that's JavaScript, by the way. So you have, for example, sensors available on the web. You have the links. You can try that later. For a heart rate sensor demo, you can connect your phone to a BB-8, a drone, right? I'm talking about the web, not a native app. And in terms of a live demo, I will do a quick one. Let's turn on again my phone. I can show you two quick demos here using the web Bluetooth API. Not sure why I need to connect it again every time. Try again. OK, there we are. So let's go to Chrome. And I know you're not seeing yet. Now you're seeing. Let's open Chrome. And I have first a quick one. This is one of the examples that you have there. You can try it yourself. So I can get Bluetooth devices battery level of any device that is offering that particular service. So here I have a smart DAC. Right? So I can basically get the current battery level from it. It says I don't have Bluetooth enabled. Why is, oh, because I have airplane mode. My fault. OK, now it's going on. So this is the web. Again, the web is trying to get information about this little DAC. Let's see if it's working, of course, because it's a live demo. It's not going to work. It wasn't connected by Windows XP. What? I don't know. Who knows? OK, there we are. So that's Edwin. That's the name of my DAC. Okay? So I can connect there. I can say pair. And now we will connect to it. It will take a couple of seconds. And finally, you can see, it's glowing. So that's because it has information from the DAC using Bluetooth. Okay? Just that. And the other example I have here, using that particular API, oops, sorry, is that one. So it connects to this other beacon I have here. So it's a very small beacon. It's, in fact, inside the box. It has temperature sensor. It has accelerometer. Also, it has a little LED. So I can connect to it. Say, I want to connect to that beam. Yeah. When I'm connected, cross your fingers. It will let me, from the website, like set the color of the LED light. That's all. It was working before, of course. It's also downloading something. Samsung Milk VR. Who knows? OK, I will continue there, but it will work. So at one point, it will work. So that's basically Web Bluetooth. Right now, unfortunately, compatibility is not so good. It's only available on Chrome under flag. So I'm using it on Chrome, but you need to go to the experimental flags and enable Web Bluetooth. Okay, so it's really experimental. So in terms of web APIs, we have device sensor APIs, web audio, web Bluetooth, and also you have some other experimental API for TV streaming that are coming, that I don't have time today to talk about them. Finally, the final short part of this talk is about VR and MR. So VR is virtual reality, and MR is mixed reality. Mixed reality is the idea of having the real reality, okay, and then mix it with some things on top of that. For example, holograms. And this is a name that is coming from Windows Holographic. That is the OS from Microsoft that will work on VR devices and also on the Microsoft HoloLens. So for VR on the web, we have the Samsung Internet Browser and the Oculus web browser. And there are also some third-party browsers. So the whole idea is I have a demo, but it's probably better to see a video, because if I put this on, it's not going to be a nice speaker view. Okay? But the whole idea is if I use, this is the Gear VR. So if I use this, I can, this is a video I took this morning. So this is what I'm seeing using the VR. So I can browse the web, right? That's the Devoxx website that will appear. So I'm inside the VR world there. That's just the website, a normal website. I can open like YouTube, go full screen, but I'm in 2D mode. But using an API, a WebR API, I can go 360 and get now an immersive experience. Okay, so now I'm in that 360 world. Okay, so this is basically WebVR. That is an API that will let you access to VR devices in your browser, Oculus, Cardboard, HTC Vive. Right now, it has just experimental support, but it's available as a polyfill, not fill. And we'll let you use it using WebGL today. Right, so you can try it on your phone directly. You have the links to do that. If you have a Cardboard, for example, you can try it on your phone. Right now, it's available on Firefox, on the developer edition, so the alpha version, let's say. It's available on Samsung Internet Browser for the Gear VR. That's the video. That's why you saw the video. And you can also download a special build of Chrome to see this working today, the WebVR API. And of course, it will work even on iOS using a polyfill, right? So you can use, and WebGL, so you can try this today. And finally, we have the mixed reality on the web. And here comes basically the HoloLens. So the mixed reality with Windows holographics. Have you seen a HoloLens? Anyone? Anyone with experience working with HoloLens? One there. So one in, I don't know, 100, 200. So the HoloLens is a device from Microsoft that will let you like open apps and even the web as holograms in the room. And I have another video for you. Right? So that's yesterday from my room. Right? You can see I'm browsing the same website. I'm not sure what happened with the video. I'm on video. OK, it didn't work. I don't know why. It stopped. But I have a HoloLens here. OK, it's difficult to test this live in the talk. But that's the same website. It's in my room. But I'm not sure why it's stopping there. Anyway, OK, there we are. So I have another tab floating in my room. All right? So it's a hologram tab. It's Edge. Right? This is the device. And the whole idea is that every Edge tab will basically appear floating in your room. It can be floating here. But the whole thing that we still don't have is that we don't have 3D. So that's a whole 3D 360 object there, right? That is in my room, right, near my Office machine. And we don't have yet that particular feature on the web. So right now, the web is just flat screens, flat holograms around you. And that's something that will change in the near future. So in the near future, if I'm wearing this, then I will be able to browse the web, right, browse Edge, and then put some tabs there around me, and finally probably getting objects, getting out of that website, right, as 3D objects, and I will be able to browse those objects directly. So that's something that will probably come to the web pretty soon, sooner than later, to be honest. So we are in very early stages, but it's going to move really fast. Right? Early stage means that probably in a year it will be finished, the spec. And we need content to get out of the flat hologram that we have today. Right? So today, every website is just a flat hologram. It's like a frame that we have there floating. And in terms of APIs, so we are in early stages for VR and MR on the web. So new APIs will appear, new concepts also, because WebVR can be used here, but the whole difference with VR is that I can walk. So if I have a hologram here, I can walk to the hologram and see the hologram from every angle. And that's something that you cannot do with VR. Okay? So that's why probably the WebVR spec is not really the one for MR. And think about mixing this with the physical web and web Bluetooth. Then you have the power, right, to connect to physical devices, to holograms, and to everything that you have in your room. So we have seen how the mobile world and IoT works today, the physical web to stream URLs from beacons, Progressive web apps as the solution to have a native app if you want, if the user wants, and re-engageability using push messages, how to connect through the web APIs that we have right now on the web, like web Bluetooth, web audio, and the sensor APIs. And finally, something more experimental is how to connect the web with VR and MR. So as you can see, this is something that is starting. Okay? So it's going to change a lot in the following years. So you need to pay attention to the abilities that the web will take in the following month. That means that I'm done. So we have 1 minute for questions. And then I will be here anyway. So any question? Tick-tock, tick-tock, tick-tock.
What about the performance? Simple phones handle all of that?
OK, so the question is about performance. Well, that seems like an advertisement for my book, right? High-performance mobile web. But the reality is that you can get really high performance if you know what you're doing. And there are techniques, patterns that will let you do that. So that means that you need to reach 60 frames per second. So we have some goals, some new goals, and new ways to measure how well you're getting into those goals. And yes, you can do it. But it's not just the normal website, and you will get really fast. You need to learn some patterns and practices to get that performance. So it's possible. Okay? It's not by default, but it's possible. Okay? Well, thank you, guys.